Yes, he said these are the calculator buttons. That is correct. Only thing on the calculator, there's no E at the end. And this is just COS, and this is just TAN. But if you ever notice those buttons, and like what are those buttons there for? They're just in the way. We will be using them this unit. So if you have a scientific calculator, you will want to start bringing them to class because...
What is it? SINE?
Yes, the SINE is just SIN on your calculator.
Cuisine?
You cannot use it on your phone.
Cuisine?
You can, but you can't use it on the test. So,
Cuisine or cosine?
cosine, COSINE. What part do you not like?
Oh.
240.
I put a triangle instead of
Cosine, come on.
Yes. Okay, we are going to draw
Wait
our...
a second, I have a question.
Yes. You forgot your question?
No,
I'm waiting.
I forgot. Does it say target?
There is no target on the paper. Tangent.
Wait, we're handwriting.
Look at, there's an N and there's an N.
You tried to be fancy.
There's no fanciness. There's a TANGENT.
Maybe space your letters.
No.
I told you.
Okay, I'll give you that on this N right here.
Me and Caleb finally agreed on something.
Okay. My goodness, you are a troublemaker.
What? Because I said spread your letters out?
No, because you're being mean to your group members.
How?
Yeah, go to that.
What did you tell him when he asked you for help?
Huh? He didn't ask me for help.
Yeah, I did.
All right. Shh. Guys. We are listening. All right. I'm going to position A right here. Now, technically, if I wanted, I could put A up in that corner, as long as I don't put it on the right angle. Okay? But A can be in either one of these corners, as long as it's not in your right angle corner. Okay. Now, do you remember when we used the, well, first off, what is this, the special side called? Hypotenuse. Okay. Now, we used the words earlier, opposite, and for next to, what was the word I used? Adjacent. Okay, what am I pointing, in reference to A, what side am I pointing to right now? Adjacent? The adjacent side, correct?
Yes.
Now, in reference to angle A, which side am I pointing to now? This side is the opposite side or adjacent side?
Opposite.
Now, I asked earlier if adjacent is next to, and I'm sitting at A, what do I call this one adjacent and not this one? Why is this not also called adjacent?
Who's Jason?
Adjacent. Because it already has a special name of the hypotenuse. Got it?
Yes.
Okay. Guys, you need to make sure you understand this. Okay, we are going to go through. I know.
Wait, how do you do this again?
We are going to go through and write our fractions. Sign will always be opposite over hypotenuse. And I am abbreviating there. Opposite over hypotenuse. I didn't give myself enough space, so I'm going to erase these. I'm going to put them back. Don't worry. It was too scrunched up for me. Okay, opposite over hypotenuse. Okay. Cosine of A equals adjacent over hypotenuse. And tangent, not target. Tangent, now, okay. tangent of A equals opposite over adjacent. Good job. All right. Now, a few things. First, remember to start bringing your scientific calculators. If you have them, bring them tomorrow as well. Okay. Questions so far? All right. Yes.
Wait, so checking the opposite is the shorter side?
Opposite, no, it's not always the shorter side. That is a very good question. Okay, for example, I'm going to cover this up, and I'm going to write this in pencil because I will go and erase. If I put A up in that corner, and did I say earlier that A could be in that top corner? Did I say that earlier, yes or no?
Yeah.
All right. Now, if I'm sitting at A and A's here, what would this side be in reference to A?
Oh, okay.
The adjacent would become the what side? Opposite, and the opposite side would become the adjacent. So, can you say always opposite's always the small side, or the opposite's always the one on the right? It depends on how your picture is drawn and what angle are you sitting at. Does that make sense? Okay, so with that being said, I will tell you right now, this is another thing you will need to work on memorizing. Okay, you need to know that for homework, for quiz, for test, for next year's math, for advanced math, for calculus math, you need to know this. All right, there is an acronym that we use. Do you remember the PEMDAS that you learned way back when?
Yes.
Okay, here's another acronym. Uppercase S and then lowercase OH, uppercase C, lowercase AH, SOCA, and then uppercase T and lowercase OA. SOCA-TOA. Now, when I learned this back in high school, I never learned it with SOCA-TOA. I just flat out memorized this and used it, and I was good. But they have this cute little acronym now, SOCA-TOA. Now, so I know. It's not a formula. This is just a tool we use to help us memorize, and let me show you how it works. First off, if you can work on memorizing SOCA-TOA, SOCA-TOA, and you write it at the top of your test, this is how it works. Are you ready?
I'm ready.
S stands for sine, and sine is O over H, which is opposite over hypotenuse. Oh. C stands for cosine. Guys, I love it. C stands for cosine, and cosine is A over H, which is adjacent over hypotenuse. And TOA, T stands for tangent, and that's O over A, please stop, which is opposite over adjacent. So if you can remember this, write it down. Can you generate this for your test? Yes, I would practice tonight on your homework. All right, so examples. If that's how you want to remember it, Peyton, then yes. Yes, you're more than welcome to. Find A. Part A, I'm going to ask you to find sine of A, cosine of A, and tangent of A. Part B, I'm going to ask you to find sine of B, cosine of B, and tangent of B. And I'm going to give you a picture. Before I do, just get that down for now. Yes. Can you get a picture? Okay. And you have the worksheet in your packet. Okay. All right, everyone have the picture. Yes? We're good? We're ready? Okay. I will tell you this. We will always say sine, but we're not always going to write S-I-N-E. It's going to be abbreviated like this. Now, I often have kids say sin of A. It's not sin of A. It's still sine. We just don't write the E. We just shortcut everything to 3 letters. Okay? So you will not say this. You will not pronounce it sin of A. It's still sine of A. No. cosine of A. Again, sometimes I'll call this cosine, and tan, I'll call tan or tangent. The only one I don't like this one, just don't call it sin, it just sounds silly. Sine.
It's a sin to say sin.
All right, so we are ready. Now remember to reduce your fractions when possible. Okay, so here is what I want you to do. If you're working with a pencil, that's good, and if you have an eraser, that's great. If you're working in pen, either trade to a pencil or don't write this next piece down because I will be erasing. Are you ready?
Yeah.
Okay. Now, A is what we're working with for part A. This is part A here. Now, I'm going to put my little pencil mark right here at A. If I am sitting at A, first off, where's my hypotenuse? The 3, the 4, the 5?
5.
Without knowing or caring where you're sitting, that will always be the hypotenuse. Do we agree? Okay. In reference to A, what side is your opposite? The 3 or the 4?
3.
The 3. So I'm going to label this OPP for opposite. And in reference to A, where is your adjacent?
3.
The 3, the 4, the 5. Adjacent is next to, so that would be the 4. So in reference to A, opposite, adjacent, always the hypotenuse.
I thought
I'm at A, so adjacent's next to, opposite is across from. Okay, so now we have enough to make our fraction. Sine of A, according to the SOH, opposite over, so 3 over 5. And do you see how it helps to have it labeled? Cosine of A, according to our CA, that's adjacent over hypotenuse, 4 over 5. It's nice to have it labeled. And tangent is TOA, not toe. TOA, opposite over adjacent, what over what? And there's nothing to reduce here, so this is your answer. That's it. All right, that's good. That's good then. All right, part B. Sine of B, not sin, cosine of B or cos, and tangent of B. All right, now this is where we're going to use our handy dandy erasers and erase these markings. Do I have to erase the hypotenuse one? No, because even if I'm at a different angle, will that still be the hypotenuse? Yes. I'm going to now put my pencil marking at angle B. And now, when I'm sitting at angle B, where is my opposite? The 3 or the 4? 4. Was that opposite to begin with? No, earlier this was labeled adjacent. Do you see why you want to be working in pencil? Okay, in reference to B, 3 is the what? Opposite or adjacent? It's next to, so it is what? Adjacent. Now this one's always also next to, but it's called the hypotenuse already. All right, so sine, I'll let you guys fill these in quickly. Remember your SOHCA, TOA. Okay, we ready? Okay. Daniel, give me the sign of B. In words first. Okay, you said 4 over 5. Can you tell me in words first? Like what over what? Okay, he said opposite over hypotenuse, so you said 4 over 5. Do we all agree with him? Good job. Gabby, give me in words cosine of B.
Adjacent over hypotenuse.
Okay, give it to me now with numbers.
3 over 5.
Perfect. Do you guys all agree? Yes? All right, and David, give me the next one. In words first. No, in words. Like up here. Opposite over adjacent?
Yeah.
And then what over what?
4 over
4
3.
over 3. Questions? Okay. Really quick, just a side note, we'll talk more about this another day. 3/5 comes up twice. 3/5 comes up for sine of A, and it also comes up where?
Cosine B.
Cosine B. Do you see that? Those are called complementary cofunctions. You do not need to know that word. That comes up in advanced math. But you do need to know that sine of A will always be cosine of B. Sine of one angle will always equal cosine of the other angle that's not A. Let's check this one. What is cosine of A? 4/5. And what is sine of B? All right, does that make sense? Sine of one angle will always equal cosine of the other. Sine of one angle will also always equal cosine of the other. Did it work? Okay, they will ask you questions like that on the test. We'll prepare more for that. I just want you to at least recognize right now. Sine A, cosine B, cosine A, sine B. Why? Because A's opposite is B's adjacent. Do you see that? And I could tell some of you are not paying attention and you're going to struggle come test day. Okay, can I move on? We ready? Okay. Number 2, find sine A, cosine A, tan A. All right. Since they're not asked, I'm still going to work with pencil, but they're not asking about B, but I'm still going to write it in pencil. So I'm going to put my pencil mark at A. Am I missing a side?
Yes.
What side are we missing?
AB.
AB, which has a special name of what? Okay, do we have enough information to find the hypotenuse?
Yes.
Using an old lesson, what is it? A squared plus B squared equals C squared. Do that now. Does anybody know what 15 squared is off the top of their head? Be careful. You did 15. 15 times 15 is 225. All right, I'll let you continue. 250. And what do we do to both sides? Square root it. Does 250 break up? 250 breaks up to, can we use 25 and 10? Are you guys okay with that? And 25 is 5 and 5. That's nice because there's a pair there. And 10 is what?
5 and 2.
Okay, so this is review from Monday's lesson. If I have the square root of
5 square root of 10.
2, 5, 5, 5. I heard some of you say it already. How many pairs do I have in here? Just one pair right here. Does it come out as 25 or 5? 5, because 5 times 5 is 25, but the square root of 25 is 5. So 5 root 25 or 5 root 2 times 5? So 5 root 10. So now, do I have enough to continue? All right. Okay. So now I'm going to go back and label the whole opposite adjacent business. Where's my hypotenuse? We just found it. Where is it? What is it? Okay, hypotenuse. In reference to A, what would I call 15? Hypotenuse, opposite, or adjacent? What would I call the 5? Now, is it because 5 is smaller that it's opposite, or because it's across from the A? Right, because if I was at B, what would 5 be? Adjacent. So make sure you get your eyes, you train them to recognize. All right, so let's find sine of A. Not sin of A. Sine of A. Oh, can you guys quickly write SOHCAHTOA over here? SOHCAHTOA. And let's use that. In words, what is sine? Opposite over? So what's opposite? 5 over?
5 root 10.
Okay, there's a lot of business going on here. I need the talking to stop. First off, can we reduce?
Yeah, you can.
These can't, but can these?
Yeah.
Oh, yeah.
Yes, because they're not in radicals, and they both divide by 5, which gives us what in the top?
1 over root 10.
1 over root 10. Now, imagine this is a test question, and you've gotten this far. You've done all your work. You did all this. You labeled beautifully. You labeled all your opposite, adjacent, hypotenuse, and then you gave me this as your answer. Why would I mark it wrong? Good job. You can't have a radical in the denominator. Do you guys remember what the process is called? It starts with an R? Rationalize. Good. Rationalize the denominator. Now, do you guys remember what we multiply by?
Root 10.
Over.
Root 10.
Okay, and I keep asking this. There's 2 reasons why. 1, root 10 over root 10 is what?
1.
Root 10 over root 10 is 1. And 1 is the what? Multiplicative identity. And what was the second reason? Why root 10 and not root 5? Because it gives us a pair. All right, in the top, 1 times root 10 is just 1 root 10, or just root 10. And without saying 100, without writing 100, what's root 10 times root 10 because it's a pair? 10, right? The root's gone. Do you agree? Root 100 is 10. Now, can I reduce these two? No. So this is the answer here for sine of A. So yes, a little bit more work, but still doable. Do you agree? Okay. Yeah. Cosine of A. All right, let's look at the ca. What over what?
15.
Adjacent over hypotenuse. So I heard 15 over.
5 root 10.
All right, can I reduce again the 5 and the 15?
Yeah. 3 root 10.
3 at the top, and because 5 goes into 15 3 times, and 5 goes into itself 1. So 3 root 10 or 3 over root 10?
3 over root 10.
All right, and is this another one we have to rationalize? Top and bottom by root 10, because root 10 over root 10 is 1, and 1 is the multiplicative identity. And why root 10? Because it gives us a pair. Now, remember we've talked about this. Does this multiply by to root 30 or 3 root 10?
3 root 10.
Why? Because the 3 is not inside the radical. If it was root 3 times root 10, could that be root 30?
Yeah.
Yeah. But the 3's not, so you cannot multiply it. Well, you can't bring it inside the radical. All right. Over 100 or over 10? 10. Because it's a pair. All right. And tangent, last but not least. In words, first, O over A stands for what over what?
Opposite over adjacent.
Opposite over adjacent, so what over what? Ooh, is that a nice one? Will we have to rationalize this one?
No.
No. But we do have to divide top and bottom by what?
5.
By 5. Okay, and you end up with a 3. So it's what? 3 or 1 over 3? 1 over 3. Okay, we do have one more. Hold on. We might. Can I just look at it and see if I want to skip it? We can skip it.
We know we looked at
10 what?
It's 15 over 5. Because it's adjacent over.
Oh, opposite over adjacent. O over H?
I got it.
Oh, it's okay. So tangent is opposite over adjacent is what she was asking. So opposite over adjacent. But I'm glad you're paying attention. Does it make sense now?
Yeah.
Okay, good.